Okay, where we are at. Now we have to solve these type of situations here, which is this very simple problem as well. I don't remember saying any complicated problem so far, because everything in this class is easy. Just needs a little bit of understanding. This car is being towed by those cables in that position. I don't understand why, but hey, yeah, feel free to do it. And then it says that the result they're asking for these two values, and they know the resultant force is directed along the positive x-axis. You know, that's the most important clue here. This is the resultant force, and it's directed over there, and it's 1250 newton. When we are doing these type of problems in 2D, and we're using forces, and we're using what is called particle, all the forces are applied at one point basically, eh, the maximum number of unknowns that I have is the same maximum number of equations that I can generate. When we are dealing with these type of situations, all the forces apply at the point, then we are doing with what is called particle equilibrium, and there are two equations that can be used for that. Summation of forces in x and summation of forces in y. Two equations, two unknowns, perfectly, we can do it. So how are we going to do this? Resolve, find components of the forces. Always, it's going to be this. In x and y, find the resultant in x, the resultant in y, solve for the unknowns. It's always the same basic general procedure that we are using here. So let's do it. First in x. For the x direction we have, for FA, we have this component. This component, which is basically the same as saying this component, just for the sake of using the angle that is provided. So what is that component? That component will be FA sine of the angle. And for FB, then for FB we have this one. Okay, what is that component? It's 800 cosine 30. And we know the resultant in x is 1250. And that will give you, or give us, equation 1. We can simplify this a little bit more if you want to, and we can say FA sine of the angle equals 1250 minus that. So it will be 1250 minus 800 cosine 30 when I pass it to the other side. 557.18, and that will be our real equation 1. Now for equation in the y direction, for this force Fa, the component will be this one. And what is that component? That component is Fa cosine of the angle, Fa cosine of that angle. And for this other one, that will be the component, which is this one, same component, and it's 800 sine of 30. But keep in mind, negative, positive, positive, pointing downward, negative. So minus 800 sine 30 equals 0. So I can say Fa cosine of the angle equals 800 sine 30, meaning 400. And that will be equation 2. And now I'm going to divide equation 1 by equation 2. You can use any method that you want to. I just like dividing it. So I have Fa sine of the angle equals 557.18, equation 1, divided by the equation 2, Fa cosine of the angle equals 400. Fa and Fa cancel out, and then you get tangent of the angle equals 557.18. I still have the number there, divided by 400. That will be the tangent of the angle, 1.3929, meaning the angle is going to be inverse tangent of that or 54.33. Done. Now the other one is the value of the force A. The value of the force A, the only thing that I have to do is get either equations, this equation for example, and solve for FA. So I can say that FA equals 557.18 divided by sine of the angle, and the angle is this value here. So 557.18 divided by sine of the angle, and that will be a force of 685.89, and I put the units now. Newton. Ready. Really easy problem. Just apply summation of forces, x and y, and solve for the unknowns. One more for the record. One more for the story.